In our last video, we talked about some nice properties that the derivative does have. In this video, I want to talk about some properties that the derivative does not have. So we said in the last video that the derivative will sort of distribute over addition and subtraction. Notice I did not say it distributes over multiplication and division. Even that second property, it says we can factor out a constant multiple. So if we're multiplying by a constant, that's fine. But if we're multiplying two functions, or if we're dividing by two functions, the derivative doesn't quite work the way you might want it to. There are some rules for handling this, and we're going to talk about that in the next section. But for now, when we encounter multiplication and division of functions, we're going to have to find a way to sort of cleverly rewrite these functions so that we can sort of get around it. And that's what we're going to do in these two examples here. So first up, f of x equals 5 minus 3x plus 4x squared all over x. So here I have this numerator, this 5 minus 3x plus 4x squared, that's being divided by x. I've got a rational function here, which really means we're dividing these two functions. Now, as much as I would like to, I can't just take the derivative of the numerator and then take the derivative of the denominator and call it a day. It just doesn't work that way. So for now, I need to find a really clever way to rewrite this function. And what I'm going to do is I'm going to take this one fraction and I'm going to split it up into three separate fractions. I'm going to take 5 divided by x minus 3x divided by x plus 4x squared divided by x. I'm going to split this up into three separate fractions. So 5 divided by x minus 3x divided by x plus 4x squared divided by x. And now what we can do is we can simplify some of these terms. If I look at the second two terms right here, I can cancel some powers of x. I'm also want to think about what do I need to do in order to take the derivative in my next step. In this first term, I see that power of x in the denominator. I know that in order to use my power rule, I need to rewrite that with a negative exponent. So I'm going to do both of those two things. I'm going to first of all rewrite this term with a negative exponent. So that will look like 5x to the negative 1 power. And then the second two terms, we can just cancel some powers of x. So 5x to the minus 1 minus 3 plus 4x. And this is still my function. I haven't yet taken the derivative. I've just found a really clever way to take this function that has a division of two smaller functions and rewrite it so that I no longer have that division. And once we get rid of that division, once we've found a way to rewrite this function, now we can go ahead and use our power rule. So our derivative, f prime of x, we're going to, for each one of these terms, multiply by the power, subtract 1 from the power, just like we've been doing. So 5 times negative 1 gives me negative 5x to the negative 2. Derivative of negative 3, well, that's just a constant, so its derivative is 0. And then derivative of 4x, that's going to be plus 4. So there's our derivative. If you want a positive exponent, we could also rewrite that as negative 5 over x squared plus 4. Either one of those is perfectly fine. So here there's really a couple steps. We want to rewrite this function to get rid of the division, and then we might need to do a little bit of simplifying or perhaps a little bit more rewriting, but then eventually we should get to a point where we can use our power rule, and that's kind of our goal in this section. Is every derivative that we're going to see in this section, we should be able to use the power rule with. Some of these, though, we just need to do a little bit of rewriting in order to make that happen. Next up, I've got g of x equals 2x minus 5. Oops, there's a typo in here. This would be a kind of an ugly problem to do. I'm going to change this to 2x minus 5 to the second power. So let me rewrite this: 2x minus 5 quantity squared. And this, even though it might not look like it, might not be obvious right away, this is a multiplication of two separate functions. I'm actually multiplying here 2x minus 5 times 2x minus 5. And if everything worked the way you wanted it to, right, if this was as easy as possible, I could just probably take the derivative of 2x minus 5 and take the derivative of 2x minus 5 and multiply those two and call it a day. Unfortunately for us, that's just not the way that derivatives work. We do need to simplify this. I think this problem is a little bit more straightforward, because if I want to simplify this function, I can just go ahead and FOIL it out. I can multiply these two. So g of x is equal to 4x squared minus 10x plus 25, or g of x equals 4x squared minus 20x plus 25. And now we've rewritten this so that it's a polynomial. It looks a lot like the functions that we were taking the derivative of in the last video. So we can go ahead and use our power rule. So g prime of x here is 8x minus 20. No more rewriting necessary after that. That is simply our derivative. So be careful and keep an eye out for problems like this, problems that have some sort of division or multiplication, because we do need to take that extra step to rewrite them first before we can jump into finding the derivative using the power rule. In some instances, this won't be possible, and that's something that we're going to be talking about later on in the next section. But for now, every single problem you see, we should be able to rewrite so that we can use the power rule.